All right, so now we're in the second module of the exploiting local dev environments, basically a tutorial, right? So, okay, so now we're starting to get more into taking all the assumptions that we learned in the first module and the assumptions, but also all the things that we refreshed upon, and then putting that into an example. All right, okay, so what is beef? Now, Beef is the browser exploitation framework. And once again, anything like right here that you see as a bullet that has this color in the notes, it will be a link. So, all right, so what does Beef do? Well, it really creates a browser botnet that can be controlled by a central server. And here's the fascinating thing, and this is on Beef's website. It's basically, it says, and I think this is a really telling quote. Beef looks past the hardened network perimeter and examines exploitability within the context of the one open door, the web browser. And that's the thing. What security assumption does this exploit? Well, it exploits many, but to me, it's really I see this as our VPN protects our network from the public internet. That is the assumption that I see being exploited here. So how does beef work, right? So let's just say Bob visits a page with malicious JavaScript, okay? And we saw this kind of earlier with Mallory's DOM XS loaded this basically hook.js from evil.example.com, okay? Now, hook.js then interacts with Mallory's command and control or CNC server. Now, through this CNC server, Mallory launches attacks from the victim's browser. Okay, and this is just, it gets kind of crazy here. So Beef really allows Mallory to do many things, but here are some items that we're going to be looking at within the scope of this tutorial. So she allows Mallory to find servers on the victim's local area network or her LAN. Okay, and it's basically including servers listening on localhost. Okay, so basically, if a browser gets this hook.js on it, the victim's browser, this hook.js can then make calls to that computer's localhost interface. So just to clarify this just a little bit. Okay. Now, also Beef can make REST requests to these servers if CORS isn't strict. And when I mean this, really mean the full gamut of CORS requests. Okay, so you're talking about put methods, etc., and some posts through kind of more of like a AJAX request. And we're going to be seeing that in a few minutes. Now here's where it gets really crazy. Mallory can then execute arbitrary JavaScript payloads within the victim's browser. So it gets pretty nuts. So we're starting to get into our demo of how to find a developer's Elasticsearch instance. Now, in this demo, we're going to be leveraging Beef's cross-origin scanner module. And basically the idea is to check for an Elasticsearch instance, or just ES instance, running locally with a permissive CORS policy. Now, here's the thing. If Elasticsearch has a permissive CORS policy, Beef can do some things to it, all right? For example, send any type of REST request to that, say, developer's Elasticsearch instance. And why is that? And that's because Elasticsearch 5.6, the Community Edition, currently has no authentication built in. And the 5.6 is still being actively maintained at the time of this recording. And this also, the no authentication, also the scope of that also includes the clustering interface. Now, Elastic, which gives some commercial kind of options for Elasticsearch, they offer through a paid through a paid option, they do allow authentication and authorization, etc. But it's I mean, just I have seen kind of Elasticsearch instances leveraging the community edition within prod, just for kind of pay, just for monetary reasons. So anyhow, we are now in the Beef UI, and let's get started. So you see us, we're kind of looking through the viewpoint of Mallory. So we see the hooked browsers, one of them, Famazon Juice, okay? And here's some of the things. You see all this metadata that Mallory can see. You see if they have Flash enabled. You can see WebRTC. You can see the page URI, cookies, right? So she can steal authentication cookies. The operating system, screen size for fingerprinting a browser, all kinds of just, oh geez, all kinds of stuff. So you're going to go ahead and put in the cores module here. And I'm just going to put in an IP range, all right? And then we will go ahead and just put in a common Elasticsearch port. So this will be searching locally on 127.0.0.1. And also 2, but that doesn't exist, as we'll see. So boom, because cores was permissive, we actually see the response here, which is from Elasticsearch. Now we're in the victims view. We go into basically the network requests, and then we can see it right here. That hook.js made a call to 1.7.0.0.1, and then we should see the response here. Boom, we see that response from that local Elasticsearch instance. And we also see 127.0.0.2 there was nothing listening on that, so basically nothing was found. All right, pretty crazy, but we will continue with this madness. Okay, so what about finding a production Elasticsearch instance that's somewhere else on the network? Now, just to rehash our previous scenario, we have a dev on a VPN. The VPN contains a prod Elasticsearch instance, and that prod Elasticsearch instance does not allow cores. All right. And maybe the DevOps engineer might have said, oh, it's locked down, so these types of beef attacks won't work. Okay. And it's safe because it's on the VPN, so we can leverage the community edition and just kind of, yeah, we'll just do it that way. I mean, hey, I mean, these types of assumptions occur all the time. Now, to find this production Elasticsearch instance, we're going to be leveraging Beef's port scanner module. And basically, it uses methods to avoid block ports or the same origin policy. All right. So even if a server doesn't explicitly allow cores, it can still see if it exists. Okay. So that's kind of the thing. And the other item is like, let's on certain cores requests, for example, on a Git, say on a Git kind of XHR request, all right, you can still see if a server is responds if it gives back an OK message, or in other words, it shows that it exists. However, the browser will not be able to have or hook.js, because of cores, won't be able to see the actual response of the server. It can still see if it exists. So that's also kind of what this port scanner module does. And also leverages WebSockets and all kinds of interesting items, like WebSockets is not scoped to the same origin policy. So all right, and here's just some future work here is you can go ahead and then script basically what we're about to see to be a whole, network range of internal, say, IP addresses. Right now, you basically just put in one IP at a time, but obviously it'd be trivial to script this. And also, for simplicity, I'm just going to just put in prod.example.com here just to make it kind of a little, I'm just leveraging some DNS for a little bit easier separation. All I did was just update my host and my Etsy host for this. And although the common Elasticsearch port number is 9200, I did it on 9201 because as you'll see in the notes, you can just do a simple Docker compose up and you can play around in this environment. So anyhow, those are some of the things just to know. So we are now logged in to kind of Mallory's view. And let's get started here. So we go ahead and put in doing the port scanner module. And then we put in prod.example.com here. And then we go ahead, put in 92.01, and debug equals true. Okay? And then it goes ahead and it does its scan. So just wait for a second. And boom. So we see a couple of ones are open. See the WebSocket showed that it was open. And then we'll switch to the victim's view. And we'll actually see in a second here. I'm just going to kind of filter down a little bit. I'm just going to go ahead and click on all really quick. It'll catch up. Cool. And then we see these last three requests right here. And here they are in another view. So we see one. So basically it tried an FTP. It got blocked by the same origin policy. Here's also the WebSockets one you see actually worked out correctly. And the prod.example.com, this one that I'm clicking on right here, basically what happened, that was that what I talked about, that get XHR request, that you cannot see the response, the browser cannot see the response, or any JavaScript within it cannot see the response, but you can still see if a given server exists. So, and once again, you would just script this module into the future just to do this process for all IPs, say, on the LAN, okay? Okay, so we have that prod Elasticsearch instance has cores enabled, okay? Well, actually, I'm sorry. Yeah, I'm sorry. Does not allow cross-origin resource sharing, that prod instance. Okay, but the dev does allow cross-origin resource sharing. So, but how are we going to exfiltrate data from that prod instance through the developer's local environment and then out to Mallory's beef server? Well, yeah, here's what I'm saying. So due to that Elasticsearch, the prod Elasticsearch course policy, beef cannot directly connect. All right, so how can Mallory exfiltrate data while covering her tracks? So here is a potential solution. Okay, have the developer Elasticsearch instance join prod as a cluster member. Okay, or, and just remember, just as a brief aside, we are leveraging Elasticsearch in basically its default default settings for Community Edition 5.6. All right, so okay, back to the point here. So okay, the other item is that we can also leverage the default functionality for the cross-cluster search feature to basically to query prod Elasticsearch without joining as a cluster member. Now, so basically, the dev environment, the developer's local environment, that Elasticsearch instance could then leverage the cross-cluster search functionality to talk to prod. That's basically all that's happening there. But from an attacker's point of view, or from Mallory's point of view, she would probably like this because there's no syncing of the complete data set. In other words, if they were joined as cluster members, a dev might look into their local environment, be like, "Whoa, why is all of prod here?" Right? Because they're syncing documents. So this way, it kind of covers Mallory's tracks. So she might be down with that a little bit more. Okay. So here's the payload, okay? So we are going to be running this on the dev Elasticsearch instance, and we are leveraging a put here, okay? And that permissive cores policy is what's allowing that. So we open up an XHR request, we're doing it to its clustering interface, and then we seed it and basically we're telling it to point its cross-cluster searches to prod.example.com, or basically you can think of um, the other Elasticsearch instance that was found by that previous search. And what is 9300? Well, that's the common Elasticsearch clustering port. Okay, so we have this payload. Now let's go ahead and run that payload on the developer's instance. So here we go. So we go ahead and put in Java here, so we can get raw JavaScript, and I'm just going to go ahead and paste in that payload, and this will run it on the victim's browser, Bob's browser. So we go ahead, click execute, then we go back over to the victim's view, and then we see it already made those requests. Now check this out. Acknowledge true. So that means it was successful. The developers, yeah, basically their environment went ahead and reached out to prod and got acknowledgement. It's pretty crazy. Okay, now let's go ahead through the developer's environment. Let's go ahead and search the prod cluster. So when you run this locally, after about 120 seconds, basically there will be some quote unquote or a password quote unquote that is seeded into the prod Elasticsearch instance. Okay, and and basically, so that's kind of what we're about to see here, and we're going to search for it. Now, here's the thing: is I mean, in Elasticsearch, I mean, if you're not too familiar with Elasticsearch, you can kind of think of an index as somewhat synonymous to a SQL table. All right, and then we are going to go ahead. That's already in prod. Okay, this sensitive data index. And then we're going to leverage the CORS request module to basically initiate this request right here on the victim's computer. And what's really going on is you see this 9200, so it's basically reaching out to localhost, and this wildcard here is saying, hey, for all cross-cluster search interfaces, basically look for the sensitive data index and just return it. And you got to pretty print it, right? Okay, so let's check it out. So we're back in Mallory's view. Okay, so type in, we're testing the CORS request. So we just go ahead, I mean, don't really worry about data or anything. We're just doing a GET request. So it wants validation, so I just put it back. So go ahead and click on execute. And then, boom, that's crazy because on the dev instance, CORS is permissive. We see the output, and then this is a secret password, as you just saw. Yep, it's right here. Passwords, this is a secret password. So pretty crazy. All right, so what led us to this craziness? And really, we'll just do a brief assumption recap. So how did this all happen? So DOM cross-site scripting allowed Mallory to control Bob's browser, okay? And here's the assumption, right? That kind of could have led to this. Client-side cross-site scripting validation is a bad practice. And then we saw a permissive CORS policy within the developer environment. And that allowed Mallory to establish a connection with the prod Elasticsearch instance. And basically, an assumption could be, oh, well, the outside internet can't interact with the process listening on localhost, so I'll just open it up. All right. And the other basically idea here was leveraging Community Edition software with no authentication. And that allowed Mallory to exfiltrate data out of the production Elasticsearch instance. And what is an assumption there? Well, our authentication is our VPN. Okay. So what are some mitigations here? Well, you can have a basic authentication proxy. Say you can sit Nginx or something of that nature between anybody and Elasticsearch, right? And there's some pros cons with that. You would have to do other items for this to work correctly, but anyhow, that is one item. Kind of what the recommended approach is really there's an Elasticsearch read-only REST plugin, and that kind of allows some auth to occur. Now, I would recommend, I have not leveraged this in production or anything, but from what I can gather on the internet, this is a highly regarded open source plugin for Elasticsearch to kind of give you some more security functionality so these types of attacks don't occur. But here's really when we go back to that 80-20 analysis, right? And I think if really, if we question our assumptions and we really move from those unknown unknowns and really question and really move to, there's a lot of things that I don't know here. So we're moving to those known unknowns. I feel that this process would naturally manifest. So that's kind of what I am hoping is the key takeaway of this tutorial. And as always, if you have any feedback, you could either leave it in the comments wherever you're seeing this video, but also please feel free to reach out. This is really my passion, and yeah, I'd love to hear from you. Thank you.